Today we're going to be looking at section 4.3, which is about acids, bases, and neutralization reactions. An acid will ionize in aqueous solutions to form H plus ions, and acids can be mono, di, or triprotic acids, which look at how many hydrogens will form. Some examples of acids are hydrochloric acid, nitric acid, and acetic acid. And then we're going to look at bases, which accept H plus ions and produce hydroxide, which has a negative charge. However, bases don't always have to be hydroxide. For example, we have ammonia, which is just NH3. And then down here we have a diagram of an acid, a citric acid, and the question asks us how many H plus ions will break off. And here, although there are many hydrogen ions here, only the ones over here will break apart, only these three, because they're attached to the carboxyl group and they're less secure. So these ones will break off over here, while these hydrogen ions will stay together with the carbons. Next, we're going to look at what makes the differences between strong electrolytes, like what a strong electrolyte equals a strong acid and base. So a strong electrolyte will always be a strong acid or base, just like a weak electrolyte will always be a weak acid or base. And strong electrolytes will completely ionize in aqueous solutions, meaning they will completely break apart, whereas weak electrolytes will not break apart fully. And we have an ionic compound, in order to determine if it's a strong acid or base, which is a strong electrolyte, you're going to see if it's ionic. And if it's ionic, then it'll be a strong electrolyte. However, if it's molecular, which many of these are, then you're going to take a look at this table. And you just have to memorize this table. And you just have to memorize this table for the test in order to determine which are strong acids and bases. And so for the strong bases, it's very simple. It's just all of the hydroxides that bond with metals in the first two groups. And then strong acids you'll memorize. There's many on here. One you notice that isn't on here is hydrofluoric acid, which is commonly known as a weak acid. Next, we're going to look at neutralization reactions, and this occurs when an acid solution and a base solution are mixed together. So here's an example where you see your acid and your base of hydrochloric acid and then sodium hydroxide will mix together and form water and then a salt, which is sodium chlorine right here. And so a neutralization will always form water plus a salt, and a salt is when your cation comes from the base and then your anion comes from the acid. So here our sodium comes from the base, sodium hydroxide, and the chlorine comes from the acid. And this is a very common formula to follow for neutralization reactions. Here we're going to do an example of this. So first you're going to just pause the video here and then finish the equation. Okay, here your answer, you're going to have magnesium chloride and then water. And you know the water forms because you have hydroxide over here and hydrogen right here. So those two are going to combine, forming water, and then you have your anion in the acid and your cation in the base, and so those will form magnesium chloride. Now you're going to write out the net ionic equation for this one. Okay, And then here's the net ionic equation. You keep your solid together because solids don't have a charge, and then you break apart your hydrogen and your chlorine, which would be right here. And then on the other side, you break apart your magnesium and your chlorine, and you have your water full over here. And then the chlorines both cancel out because they both have a charge of -1, and there's 2 of them. But then the hydrogens and the magnesium stay in the equation. So here's your net ionic equation for that. And the last thing we're going to look at for neutralization reactions is gas formation. And these are just some helpful tricks. So hydroxide tends to react with hydrogen to form H2O, which we saw in the last equation, the last problem. Next, hydrogens can join to form hydrogen gas. And so you're going to just be careful to find and look for any gases that may form in your equation. For example, you can form carbon dioxide or hydrogen sulfide gas. And here is just some real-life application. Antacids help digest food, and because they contain hydrochloric acid, and then acid inhibitors decrease acid production. So just remember these 2 definitions because they may show up on the test for 1 or 2 questions, multiple choice questions. And finally, let's do a practice problem. It's my handwriting. So, first, let's go ahead and solve this equation, seeing how these break apart. So pause the video here and complete the equation first. Okay, so it's a little blurry, but you have your 2 acetic acids combine with the barium hydroxide, and in these you have your acid and your base, so they're going to form a salt and then water. And you have your H2O over here, and that's going to take the hydrogen from the end of this carboxyl group and these hydrogens over here. Wait. Yeah. And those are going to form the water. And then here you're just going to have barium acetate, because barium has a positive charge and then acetate has a negative charge, so those form your salt. Next, write out the net ionic equation. Okay, so the net ionic equation, your acetic acid is going to stay together, and then your base is going to break apart into barium with a 2+ charge and your 2 hydroxides, and then those are going to go into barium and then acetate, which has a negative charge, and then water stays together. And so the only 2 things that you're going to cancel are barium, and then your final net ionic will be this without the 2 bariums on each side because it's canceled. Hopefully this was helpful. Review on 4.3.